factors that contribute to stars' brightness and all the things that I'm going to answer these facts. So, what factors contribute to the star's brightness? So, distance, temperature, and size. Distance is like if you had a super small thing, if you had like a super small star, like let's see here. If we had like one of these stars like down here, compared to one of these super giants, and you put this super giant like way far away somewhere over here, and you put this one like if this is Earth over here, and you put it like really close to Earth, it seems super big to you, and then the big one you would put over here seems like super small, and that's like that's the distance. And then temperature. Okay, so temperature, it's really confusing. Don't think of when you turn on a faucet, the warm water is hot and the cold water is cold. The the blue is increasing temperature, so the red is the coldest it can get, and the blue is the hottest. So if you had Sirius B, it's way hotter than Sirius, and Sirius B revolves around Sirius. Sirius B revolves around Sirius, and that makes it so that this one's hotter though. Like if you put this closer, this is kind of with distance. If you put this one closer, it's way brighter than this one. Farther, it's way darker. And then with that, it's temperature. This is like in the middle. This is the hottest it can get. This is the coolest it can get. And then size. Oh, size. Size gives us the like some stars can be insanely small but super cold, and some stars could be like super giants. These let's see here. So this one right here, this is way bigger than this one, but it doesn't. Well, sometimes it depends on the size. But we could have. Let's see here. We could have this. Look at this. Betelgeuse. Look how big it is, and it's still really cold. Compared to look, this is really hot, but this one's really cold. Sometimes it doesn't matter about the size. Alright, and then the star's brighter is determined by its distance. So like this, you put a, you give like a, you, so if you're holding, so in this picture it looks like you're holding a torch. If you're holding a torch super close to you, it's really bright. If you're holding it farther, it like gets dimmer and dimmer, and it doesn't make a difference. Alright, so LeBron and Trina are talking about our sun and other stars. Trina argues that the sun is much larger than all the other stars in the sky. She also explains that most of the stars are about the same size as each other and the same distance from Earth. LeBron disagrees. He explains that the sun looks larger than the other stars because it's closer. He argues that the other stars vary a great deal in size and distance from Earth. Who is correct? And explain your answer. So Trina argues that the sun is much larger than all the other stars in the sky. I disagree with her, but I agree with LeBron. I mean, like his name's LeBron, you know. And she also explains that most of the other stars are about the same size as each other and the same distance from Earth. And then, so if they're the same size as each other and the same distance from the Earth, so the same distance from Earth, but they're not all the same distance. Like look in this picture. Like, what if this whole thing was actually the distance of the thing? So the sun is farther away from the. So think about our sun and our moon. So our sun. So if this is our sun, no, if this is the Earth, this is our sun, and then like right here's the moon. The moon, it looks way smaller, but it's closer. The sun looks way bigger, but it's farther. And then LeBron disagrees. He explains that so LeBron is correct, and I think LeBron is correct because not all stars are the same size, and they're not all each the same distance from Earth. I mean, he also agrees that the other stars vary a great deal in size and the distance from Earth. Yeah, LeBron is really correct. Like, he's way more correct. Alright, so spectral glass color. So bluish. So the color. This is really the temperature matters. So if it's reddish, then but it's lower. Like it could be 2,000 degrees to 3,950 degrees. And luminosity, it's only point. It's only 0.6. So that's not as. So it's like not as
without
bright.
the less than 10 part.
Like if you look in the night sky, you see like all this different stuff. So if we go night sky. Night sky. So look at it. So if you look at the night sky, like there's probably stars somewhere in here. Like there might be a star here, and might have less luminosity. And then once you get orange, it does that. Yellowish, that. Yellowish white. So white is like in the middle. It's like the most even temperature. Bluish white is like our sun. Well, no, our sun's yellow here, but it's in like the white part-ish. And then when it's bluish, it's insanely hot. And then the sun, the larger of two stars with the same temperature at the same distance is brighter. Yeah, if it's bigger than this one and it's the same exact distance, the bigger one would be brighter. So and that's what the factors contribute to the star's brightness.